Let's have a look at question 3b, part 2. Okay, so we have a information about this X-ray machine from the question above, and we went through, and you can see there I've just noted down what the expected value and the standard deviation were from that. So the information in our question talks about costs. So it talks about company A has a one-off fee of $69,500 plus an additional $350 per month. Then we've got some information about company B, and they've got a one-off charge of $65,000 plus an additional charge per repair. Okay, and we have been asked to discuss which has the higher variation in the total costs. So what we need to do is identify what's happening here and form some equations. So I'm going to take you back to, first of all, to the expected values and our standard deviations. When we talked about that value, that variable n, if you go back to the definition of it, this talked about the number of repairs for the X-ray machine. Okay, now that's important to know what this is, because when I come to looking at these costs, I need to know which ones will include this variable and which ones won't. And so company B has a cost per repair, whereas company A has a cost per month. And so companies B, when it does a cost of repairs, that is explicitly connected to our variable N. Whereas a cost per month, that has got nothing to do with the number of repairs. Okay, so that cost per month, that is just means, well, I've got 12 months per year and I've got 3 years, because this is hiring it for a 3-year period. So that's what that information refers to. So let's write ourselves a couple of equations. So I'm going to start with company A and say, right, if I had to work out the total cost for company A over this 3-year period, it has a one-off fee of $69,500 plus $350 for 3 years and it's per month, so 12 months per year. So if we were to go and work out that, so I'm going to do 69,500 plus 350 times 12 times 3. That gives me a total cost of 82,100. Okay, so that is the equation as it is for company A. Now let's have a look at company B. And for our total cost equation for company B, we are told it's a one-off fee of $65,000 plus, and it's an additional $10,000 per repair. So times N, which is the number of repairs of that X-ray machine. Okay, so those are the two equations. And now what we need to do is discuss which of those has higher variation in the cost. So my first question is just for you to think logically and go, okay, company A, it costs $82,100. Is there any variation in that cost? And the answer is no. There is absolutely no variation in that cost. It's a one-off fee, it's a cost per month, there is no variation in that. Okay, so that's what we want to first of all note. So there is no variation in the total cost using company A. Okay, then we want to think about company B. So company B, we've got an equation for that cost. So is there a variance in it? Yes, there is, because we've got the variable N in there. So that means there is going to be some variation. And if we think about our expectation algebra formulas, so this is the one from the sheet, we are talking about an AX plus B situation, okay, a linear combination. And here is our variation formula, a squared times the variance of x. So in our case, if we have the variation of, and the equation was 65,000 plus 10,000 times n, that means the 65,000, that's the number by itself, so that's our value of b, and 10,000 is the number in front of the variable n, just like this variable x, then that is the value of a. So we now need to do a squared times the variance of that. So we're going to do a squared, which is 10,000 squared, times the variance of n. Okay, and so variance of n, we need, well, what we found from the previous question was we found the standard deviation of n was 0.9221. So the variation of n is equal to that standard deviation squared. So in this case, our standard deviation squared is 0.9221, and I need to square that to find the variance of n. So if I get my calculator, I can go 0.9221 squared is 0.8503. So the variance of n is 0.8503. So now I can substitute that into this equation here and go 10,000 squared times 0.8503, and that times 10,000 squared is 85 million. 85026. 841. Oh, and I've got an extra 0 in there. Okay, so that is the variation in the company B. And so we could leave that as a variation, or we could turn that into a standard deviation. And that would mean take the square root of that. And doing the square root of that gives me 9,221. So that tells us the variation. It varies. It's got a standard deviation of $9,221. Okay, so I can say, oh, not that. So up here I can add a comment and say company B has a standard deviation of 9,221, which is more variable than company A. And there we go.